am Lauren Lusk, and this is my 5E science model. It is intended to be for first grade students. They would have been in the process of studying weather, so this is to go along with that, and it's a lesson on condensation. So this is Nathan. He's graciously being my first grader this evening to help me with the experiment. So I'll go ahead and say teacher time in, and we will begin. Class, now I have a question for you. Have you ever been riding in a car and you noticed that the windows seemed cloudy somehow? Maybe you drew a picture on them, maybe you blew on them to, make more of that cloudiness. Have you ever done that? Yeah, you have? And now, where do you notice that kind of cloudiness that you see on those windows? Is there anything that usually has to happen that you've noticed?
It's in a car.
Yeah, it's usually in a car. That's very good. Now, do you think that can happen all the time? Does that happen every time you get into the car?
No.
No, it doesn't? Okay, well, let's just do a little experiment to see if that works. Now, I've got a piece of glass here. It's a little bit thinner than the glass in your car, on your car windows would be, but still a piece of glass, same properties. I want you to try to blow on it and see if anything happens. Now, can you see your breath on that very well?
No, not really.
Not really? Okay, so you can see a little bit, but not much. Now, I'm going to give you a second piece of glass, and I want you to tell me what's different about this piece of glass.
You got this one out of the freezer.
I got that one out of the freezer. Right, now I want you to try breathing on it. Now what happened? What does it look like?
That's frosty.
It's frosty, yeah. Where do you think that frost might come from?
Comes from my breath.
Comes from your breath. Very good. I think that you are probably right in that. How could you prove that it comes from your breath? What was different about those two pieces of glass?
This one was colder.
That one was colder. And what is your breath? When it comes out, what temperature would you guess that it is?
Warm.
Warm, yeah. I would agree with you if you would breathe on your hand. You can feel how your breath is warm. Now, what did we notice with our first piece of glass?
It didn't show up as well.
It didn't show up as well because it was what temperature?
Room temperature?
Room temperature, very good. Now, what about this? Did your glass show up better or worse on this piece?
Showed up better.
Showed up better, and why do you think that was?
Because it was colder.
Because it was colder. So, what could you hypothesize about the temperature of the glass and the temperature of your breath?
My breath was warmer than the glass.
Mm-hmm. Very good. And what about the glass? What temperature was it when you were able to see that?
The cold one or the warm one?
The cold one.
It was a lot colder.
It was a lot colder, and your breath was what?
Warmer.
Warmer. Very good. Now, if I'm looking at that, I think that we can form some hypotheses about why that might be. What we're studying today is called condensation, and that's a big fancy word that scientists use to say that something is becoming more concentrated or there's more of it in one area. In this case, little tiny water droplets. Do you realize that this on the glass is water droplets, and that's why you didn't see it?
No, I didn't.
No, you didn't. When you breathe out, when you're breathing onto that glass, what you're doing is your breath is warm, like we talked about, and it's meeting that cold. And when they combine, it condenses the water vapor that's naturally in your breath. You know how our bodies are made of water, and we have, spit and different things in our mouth. But you're breathing onto that, and it's creating condensation and leaving it on that glass. That's why we can draw pictures in it, we can draw our initials, anything. It's because it's that water vapor. You can also feel that and feel how it feels watery. So, based on that, let's do another experiment. This time, I'm going to fill this up. Teacher timeout. In a minute, I will fill this up, and we will go ahead and do the experiment. Right now, it isn't all the way filled up, obviously. Teacher timeout, I'm going to finish explaining it to him. So I'm going to fill this up first with cold water. Then I'm going to drop a match into it and put some cold over it, and let's see what happens. We talked about how it seems like it takes warm and cold in order to make that condensation, doesn't it? So we'll see if the cold in cold works, the cold water and the cold ice, or we'll do it a second time and we'll try warm water and cold ice, and we'll be able to see which one causes the condensation. Teacher timeout while I get the materials. Time in. All right, so can you fill that bottle and tell me if that's water and down there is warm or cold?
It's room temperature.
It's room temperature? Yeah, if we put our finger in there, we felt it, we would feel that it's a little bit cold. So it's not quite hot, but it's cold. All right, so you obviously wouldn't let first graders do this part, but you would be able to show them the bottle of water. Teacher time in. What do you see happening? We might have to do more than one. Sometimes it works better if you do more than one. And we'll try it with more than one to make it work a little better. So we can't quite see any changes. Alright, so I place this over here. Now, what do you see happening? Has anything changed in the bottle?
Not really.
Not really, no. You don't really see anything different. It looks the same. So that's our cold on cold. So teacher timeout. At this point, the students would be writing down in their observation logs what they saw with the cold. So they would write cold, they would write down, didn't see any changes, or whatever else they noticed, if they noticed anything else before we moved on. Teacher timeout while I get the rest of the hot water going. All right. Teacher time in. Now, I want you to feel the bottle now.
It's warm.
It's very warm.
Yeah.
All right, so try it again. All right. Now what do you see happening?
It's getting foggier.
It's getting foggier, yeah. We can see that it's getting foggier right here. Now, let's think that through. We talked about when we were working with the glass that we noticed that there had to be cold and there had to be warm. So can you tell me what the cold and what the warm parts of this next experiment was?
The ice was cold, the water was warm.
The water was warm. Now, what happened when we tried it when they were both cold?
It didn't work.
It didn't work. Now, why do you think that we could see it with our breath because we breathed and there were water particles in our breath that came onto the glass? Why do you think that this one, you can see it so much better? You can actually see that cloudy stuff. What is the cloudiness in the bottle?
Condensation.
Condensation, right. And if you look in here, you can even see the condensation if you look through the neck of the bottle. A little bit. What do you think? Why do you think? What did we add from what was different? We had the glass first. What did we add to this experiment that maybe might have helped us see that condensation?
The warm water.
The warm water, yes. We kind of had the warm water with our warm breath. What else did we add to this? Can you think of anything?
The matches.
The matches, exactly. What do matches produce?
Fire.
Fire, and from fire comes?
Smoke.
Smoke, exactly. Up in clouds, we talked about clouds a little bit already in our unit, but when clouds occur, part of the reason that we can see the clouds is because those water particles get trapped on the smoke in the air, or the pollution, or different things, different air particles, dust that we don't necessarily see in the air, but that's why you can see the clouds. So essentially, we have just made a cloud in a bottle. The smoke trapped all that condensation, and it made a little tiny cloud, or what's like a cloud in this bottle that we can see. I know, it's pretty amazing. It's pretty awesome. I want you now to go back to your seats and discuss with a partner, and I'll be around to answer any questions that you have. After that, if you would please, after talking with your partner for 1 or 2 minutes, I would like you to get out your science journals, which you should already have out because you've been taking observations, and turn to the reflection place, and please write me one thing that you learned that you didn't know, and one question that you have. We'll continue to look at clouds over the next few days and talk about how they're formed. We might explore this experiment a little bit more, but you've done a great job, and you may go discuss with your partner. Teacher timeout. This would basically end the experiment. Is it not? Oh no, it has been recording. Sorry. This has basically been the 5 phases. Right now, we would be in the evaluate phase. Part of the evaluation is looking at the students' reflections, what they wrote that they learned, what they still don't understand about the experiment and clouds and condensation. During this time, I would be out in the room circulating, listening to students talking, answering any questions they might have, or asking them questions to lead them to those answers, and asking them about what they still want to know. So this has been my 5E model of a science lesson. I hope you've enjoyed it. Thank you so much. Bye-bye.